original function, we say that is y equals to fx, undergo some transformations, and that becomes y dash equals to fx dash. Okay, so we name the original function as y and x, and the new function as x dash and y dash. Okay, so f dash y dash, x dash y dash is called the resultant function. So there are three types of transformation. Okay, we have translations, we have dilations, and we have reflections. Okay, the order of describing dilation, translation, and reflection is important. We normally go to the DRT order. So dilation first, then reflection, and then translation. Okay, we go through that step. So the basic shape of the graph after transformation will not change. For example, if it's a parabola, that will still be a parabola, but like maybe fatter, maybe taller, maybe move to the right or left, but the basic shape will not change. Okay, so therefore, say, for example, y equals to 1 on x will not be transferred to y equals to 1 over x squared because the shape has been changed. So we cannot transfer different type of graphs, but there's one exception, which is the sine and cosine graph. Sine and cosine graph can be transferred to each other easily because the sine graph and cosine graph looks exactly the same, but like there's some shiftment in between. Okay, so mapping. My method is called mapping. Mapping is the best method I find. Like I can do transformation questions. It is like a complex method. You may think, oh, it's too long, too many steps, but I find it's the most effective way to do transformation. Okay, translation is describe a horizontal or vertical movement, going up or going down or left or right. So what mapping methods really like talking about? So if we say translate A units to the right or translate A units in the positive direction, okay, all of these are the language of talking about transformations. Okay, so you need to use this language to describe things. Do not create your own way to describe things. Okay, at least are the correct way how you can talk about transformations. So if we say translate A units to the right, okay, so what we're looking for is this thing here. So x dash, which is the new function, okay, it's the new x. The new x equals to what? The new x equals to x plus a. Okay, new x equals x plus a. One thing I want to say before like I go through this method. Okay, mapping method, never think about the reverse way. For example, if you're looking at two questions, if that's an x minus 2, you say, okay, moving to the right for 2 units. But in mapping, minus 2 is moving to the left, plus 2 is moving to the right. Okay, 2x is dilation by a factor of 2, not a half. Okay, so mapping is what kind of thing you see, you describe as exactly the same way. You are not thinking about the reverse way. And that's another thing why I really like mapping method. Okay, so if I say translate A units to the right, I will say the new function equals the new x equals to the old x plus a. So if I go in left, so the new x will equals to the old x subtract a. And same happen for the y going up and going down. So it's always the new y equals to the old y plus something, old y subtract something. Okay, so that's for the first one. It's the easiest one. We talk about moving horizontally or vertically. So find the rule for the image of the graph. Y equals to 1 on x and a translation of 2 units in the positive direction of the x-axis and 1 unit negative direction. Okay, for y-x-axis. So what your new x dash will be? Okay, your new x dash will be the old x plus 2. Okay, and okay, I know you can do this really easily by give me the answer in 1 second, but I want to go through the basic and we can do other questions really easy. And the new y will equals to the old y subtract by 1. Okay, so the new y equals to old y subtract by 1. And remember, this function is the original function. Okay, that's the original function. Original function is in terms of x and y, not x dash, y dash. And now what you're trying to find is x dash and y dash. So you will make x and y to be the subject in terms of x dash and y dash. Try to substitute back to have a function include x dash and y dash. So therefore, x will give you x dash subtract by 2 and y will equals to y dash plus 1. Let's sub these things into y equals to 1 on x. So y equals to y dash plus 1 and 1 over x dash subtract by 2. So your y dash will equals to 1 over x dash minus 2 and then subtract by 1. So the resultant function will be 1 over x minus 2 subtract 1. Okay, so that's the basic. That's how I use mapping method to do all the type of questions. Okay, so give you the original one. You need to make x, y to be the subject because I want to substitute that into the original function in order to get x dash and y dash graph. Okay, next one. Find the rule for the image of the graph, y equals to that. Okay, that's the original because I'm asking to find image, which is find x dash and y dash. Okay, and a translation of 3 units in the negative direction of x-axis. So you first will write what you knew x will be. You knew x will be the old x subtract by 3, and 2 units in the negative direction of y-x-axis. So you knew y will equals to the old y subtract by 2. Because I want to find x dash and y dash, I need to make x, y to be the subject in terms of x dash, y dash. Therefore, x will equals to x dash plus 3 and y will equals to y dash plus 2. Okay, now I can put that back into the equation. So y will be y dash plus 2 equals to x. So x equals to x dash plus 3. And remember to put the plus 1 still. Okay, it's not going to change the plus 1. So x become x dash plus 3. So therefore, we have y dash equals to x dash plus 4 squared minus 4. So y will equals to x plus 4 squared minus 4. I just get rid of the dash, and that's my resultant function. Okay, that's my resultant function. Okay, any questions about this? No? Okay, so let's have a look at what is type 1 question. Okay, what is type 1 question? Type 1 question will give you the original equation and give you the word descriptions. Okay, word descriptions about transformation. And another special type will be matrix. Okay, giving you matrix will be the same as giving you the word description. We will talk about matrix later in the chapter. And we are going to write the new equation out. Okay, give you the original one, give you what kind of transformation has been applied, and ask about what's the resultant function. So the step 1 will be according to the word, write out the equation, new x equals to what, new y equals to what. Second step will be rearrange the equation and to make x and y to be the subject. Okay, number 3 will be substitute x in terms of x dash and y equals to in terms of y dash into the original function. And then make y dash to be the subject to find the new equation. Okay, that's type 1, which we have done like originally here, example 1. Okay, that's the question in example 1. So example 1 is type 1 question. Let's have a look at what's type 2 question. So example 2 is a type 2 question. So this type 2 question is giving you the original function, give you the resultant function, and ask you to describe what has been applied to this equation to make from the original to the new equation. So the method I do this type of question will be, first of all, make y and y dash, distinguish between them. Okay, that's the original equation. That's the new question, new equation. So I'll distinguish between x dash and y dash. Okay, and second thing is I only leave the model on the right hand side, and all the constant, what things has been multiplied all to the left hand side. So in other words, what we have been left for this one will be only the square root. Okay, the square root is the model of this question because I'm trying to take square root. This is a square root question, so I only leave square root on the right hand side. Anything else will be go to the left hand side. So same one with this one. Y dash plus 1 will equals to square root x dash plus 2. Only leave the square root on the right hand side. Okay, so what can be the model? Something squared, that can be a model. 1 on x, 1 on something can be a model. So we only leave those kind of things on right hand side. Any constant will be transferred to the left hand side. And next thing we're going to do is equivalent both sides. Okay, equivalent, make both sides equivalent. So y minus 2 2 will equals to y dash plus 1. And x minus 1 will equals to x dash plus 1 because the two equations will apply to each other. So we equalize both sides and we'll make y dash and x dash to be the subjects because I want to see what's the new y compared to the old y, okay? What's the new x compared to the old x? So y dash will equals to y minus 3 and x dash will equals to x minus 3. Okay. So what has been applied here is translate, I will write it here. So it's translate 3 units to the right and translate 3 units down. Okay, you can see y equals to the old y subtract 3 and the new x will equals to the old x subtract by 3. Okay, so it's moving both sides by 3 units. Okay, moving left. I'm writing this wrong. Okay, this should be left. Translate 3 units to the left. Okay, moving to the left. Old x subtract 3 and translate 3 units down. Okay. Okay, the next one will be like a special type. There's no, like, not telling you what exactly the model is, but like give you fx. So fx is the same as model. What you substitute in the bracket, that is the thing what you want to leave on the right hand side. So your y will equals to fx. Your y dash minus 2 will equals to fx dash minus 3. Okay, so I want to make that into this form. So only leave f bracket on the right hand side. Okay, everything else to the left. So y will equals to y dash minus 2 and x will equals to x dash minus 3. So y dash will equals to y plus 2 and x dash will equals to x plus 3. So this is translate 3 units to the right. Okay, the old x will be plus by 3 and then translate 2 units up. Okay, that's the 2 transformation applied to the original one to make it into the new one. Okay. So this is type 2 question. Type 2 question will be giving you the original and the resultant equation, which is after transformation, and ask you to describe what kind of transformation has been applied. So step 1 will be mark the transformed equation as x dash and y dash, and put the rule on the right hand side and all the other coefficients on the left hand side. Equalize both sides and rearrange the equation to make x dash and y dash to be the subject and describe what has been applied. Okay, so that's type 2 question. Okay, the next thing we're going to talk about is dilation. Okay, dilation is describing a stretch in horizontal or vertical direction. So it's stretched this way or this way. Okay, I can make it shorter, make it thinner. So dilation by a factor a from the y-axis, or we can say dilate by a factor of a parallel to x-axis, or I can say dilate by a factor of a in the direction of x-axis. Okay, so the best way to talk about is the first one. Okay, the best way to talk about is the first one. Okay, from y-axis is actually changing the x values. From the y-axis is actually changing the x value. From x-axis is actually changing the y value. Okay, it's opposite. So dilate by a factor of a from y-axis. Okay, that's y-axis. From y-axis, it goes from this way. So it's changing the x value, not the y value. From y-axis is stretched from this way. Okay, from that is stretched from here. So stretch that way is actually changing the y value, not the x value. Okay, do not mix between that. So how we can use mapping to do this? Okay, the new x dash will equals to a times the old x. And the new y will equals to b times by the old y. Okay, so that's the two direction of stretch. Okay, that's easier than that translation actually. So a first. Okay, stretch ax is dilate of a factor a from the y-axis. Y dash equals to by is dilate by a factor of y from the x-axis. Okay. So the next one is reflection. So reflect in the y-axis will be, that's y-axis, reflect from here to here is changing the x value. Okay, 2, 3 will become negative 2 and 3. It's changing the x value. So the new x will equals to the old x minus. Okay, the new y will equals to the old y minus, which is reflect by the x-axis. Okay, that's how we can write reflections. Okay, we talk about dilation and reflections together. Okay, let's have a look at example 1. Write down the equation of the image obtained by y equals to 1 on x squared. Is transformed by a dilation factor of a half from the y-axis. From the y-axis is changing the x. So the x dash will equals to a half x. Okay, a dilation factor of 2/3 from the x-axis is changing the y. So y dash will equals to 2 on 3y. Okay, so the old x times 2 on 3 will be the new y. And remember, I need to substitute that back. But now the equation is in terms of x and y. So I need to make x and y to be the subjects. So the old x equals to 2 lots of new x. So is that? And y equals to 3 on 2 y dash. Okay, putting that back. So 3 on 2 y dash will equals to 1 on 2 x dash, the whole thing squared. So y dash will equals to 2 on 3 times 1 over 4 x dash squared. So y will be 2 over 12x squared, which is 1 on 6. Okay, y equals to 1 over 6x squared. Okay, next one is reflection by the x-axis and then reflection by the y-axis. So the new x must be the old x times -1 and the new y will be the old y times by -1. So x will be negative x dash and y will be negative y dash. So put that back. So negative y dash equals to 1 over negative x dash, the whole thing squared. So y dash will equals to -1 over x dash squared. Okay, there's no negative on the bottom. So I can take off the x dash and y dash. So y equals to -1 over x squared. Okay, in example 2. Example 2 is not a hard question, but I want to show you something. Okay, so if I can say there's a dilation from the x-axis by a particular vector, I can dilate that. I can have the same result by dilate that from the y-axis by a different factor. Okay, I can always dilate by 2 directions by different factors. Okay, I just want to show you this. I have my original equation as y equals to square root 2x and my y dash equals to square root 3x dash. Okay, if I can talk about this, I will say, okay, the first way I can say is y will equals to y dash and 2x will equals to 3x dash. Okay, so y dash equals to y. There's no change in the y values. But x dash will equals to 2 on 3x. Okay, x dash will equals to 2 on 3x. Because I want to describe what kind of things has been applied, I need to have the form that the new x equals to how much old x. Okay, that equals to 2 on 3 of the original x. So I can say this is a dilation by a factor of 2 on 3 from the y-axis, because it's changing the x value, so it's from the y-axis. But another way I can do is y equals to square root 2 times square root x. Square root 2 then become a factor, like a coefficient. So y over square root 2 will equals to square root x. Then y dash will equals to square root 3 times square root x dash. Then y dash over square root 3 will equals to square root x dash. Now let's have a look. Y over that equals to y dash over that. X will equals to x dash. Y dash equals to square root 3 over square root 2 times y. Let's rationalize the denominator. That's square root 6 over 2 times y. If describe this dilation, there will be dilation by a factor of square root 6 on 2 from the x-axis. I can dilate by different ways. They are all correct answers. And any one of that is a correct answer. Or even what I can do is y equals to square root 2x. And y dash over square root 3 will equals to square root x dash. Y will equals to y dash over square root 3, and 2x will equals to x dash. Y dash will be square root 3y, and x dash equals to 2x. Then I can say this is a dilation by a factor of 2 from y-axis. Then dilation by a factor of root 3 from x-axis. I can stretch that by two ways. Stretch from this way and a little bit from this way, and I can still result in the same equation. If you like, I can create even more for you, like different ways, but I'm not going to do that. So I think 3 examples is enough to show you that dilation is not only happens in one way. If you give me a correct factor and give me a correct direction, and your answer will be correct. So you can do all of these ways. You can do all of these ways. Any question about this? Now they're all easy questions. They're all easy questions. You can really do it by looking at it and put the values in. But now let's do some combination questions. Let's do some combination questions, and that's when question become harder. The graph of g is obtained from the graph of function with rule fx equals to x squared. That will be y equals to x squared. We don't like to use fx, we use y equals x squared in transformation. By a translation of 3 units in the positive direction of x-axis, and then a translation of 1 units in the negative direction. What I'm trying to do for this question, not do A, B, C, let's do all the transformation at the same time. Let's do everything at the same time. So one step by one step. Translation of 3 units in the positive direction of x-axis, then x dash will equals to x plus 3. And then translation of 1 units in the negative direction of y-axis, then y dash will equals to y minus 1. The next thing is, I don't want this. So the next thing is a dilation of a factor of a half from the y-x-axis, which is changing the x to a half. Okay, because I already have the dilation, I need to have a bracket and put a half in the front. Okay, needs a bracket here. You can't directly times a half in the front because you apply translation 3 units to the right first and then followed by dilation. Okay, your order of transformation will be exactly the same as the calculation orders. Bracket first, times, divide, and then you have plus minus. Okay, so bracket times divide and then plus minus. The next thing is a reflection in the x-axis, which is changing the y value, right? In the direction of x-axis is changing the y value. So we will negative the whole thing in the front. Okay, you negative the whole thing in the front. Okay, the next thing we talk about is then a translation of y units in the negative direction of y-x-axis. Okay, you will subtract that further by 1. Okay, negative direction in the y-x-axis, subtract that by 1. And then a dilation from the x-axis of a factor of a third. From x-axis, which is changing the y value. How much you have changed it? By a third. Okay, you bracket the whole thing here and times that by a third. Okay, let's apply all these transformations in and what I can write out. Okay, x dash and y dash will equals to that. Okay, will equals to that. So if you want to find the resultant function, what you will do is make x, y to be the subject and substitute that back into the original equation. So let's make x to be the subject. Okay, if I want to make x to be the subject, x will equals to 2x dash and minus 3. Okay, y just need a while to do it. So y dash 3y dash plus 1 will equals to minus y minus 1, like this. Okay, you minus both sides, minus 3y dash minus 1 equals to y minus 1. And then y will equals to minus 3y dash. Okay, plus 1 on both sides. So your x will equals to 2x dash minus 3 and your y will equals to minus 3y dash. Okay, let's put that into the original equation. So it's negative 3y dash equals to bracket 2x dash minus 3, the whole thing squared. So y equals to negative a third. Okay, I'll take a 2 as common factor, and then that's x minus 3 on 2, then whole thing squared. Then y will be minus 4 on 3, x minus 3 over 2, then squared. Okay, 2 needs to be squared and x minus 3 over 2 needs to be squared. And times the 4 in the front, that's y equals to minus 4 on 3, x minus 3 over 2 squared. Okay, that's how you do this type of questions. Okay, doesn't matter how many things it has been talked about, you just keep writing that in your equation and then make x and y to be the subject. Any questions? No question? No? Okay, let's look at example 2. Example 2 has 6 kind of transformation here. Okay, 6 kind of transformation here. The class finished at 11:25, so I'll give you 3 minutes. Try to think about how to do this question, okay? I'll give you 3 minutes to think about how to do this question. Just think by yourself, okay? Do not discuss with your friend. Just have a think about how you can write this. Okay, there are 6 kind of transformation here. Okay, there are 6 kind of transformation here. Have a think about how you can write it out. Okay, how you can set up x dash equals to, y dash equals to, and how you can substitute back. Okay, I think it's enough time. Because transformation question will be a multiple choice questions, you won't spend this long on this. Okay, or a short answer question. It's only 1 or 2 mark question. So you shouldn't spend this long. If you can't find the answer yet, you need to hurry up and do more exercise. Okay, translation 2 units in the positive direction of x-axis. So your x dash will equals to x plus 2. Okay, x dash will equals to x plus 2. Then dilation by a factor of a half from the y-x-axis is changing the x, so it times a half in the front, and with bracket x plus 2. Number 3 is reflection in the y-x-axis is changing x again, so it's a negative of all of that. So x dash will equals to negative a half times x plus 2. Okay, and then y dash will equals to a reflection in the x-axis is changing the y value that become negative y. And then translation 1 units down. So we will subtract that by 1. Okay, subtract that by 1. And then dilation by a factor of 4 from x-axis. Then the whole thing you need to times that by 4. Okay, it's whole thing times by 4. Okay, the order must be exactly as the calculation order. Okay, the order you describe your transformation, that will be the same as your calculation order. So you need a bracket there, and then times that by 4. So let's make x to be the subject. X will equals to negative 2x dash minus 2. The next one will be a quarter y dash plus 1 equals to negative y, and y will be negative a quarter y dash, and subtract that by 1. Okay, we have this and we have this. Let's substitute that back. Y will be negative a quarter y dash subtract by 1, and x will be negative 2x dash minus 2, and you still have the plus 2 there, and then you square it. So that is negative a quarter y dash equals to bracket minus 2x dash bracket the whole thing squared plus by 1. And then y dash will be negative 4 bracket 4x squared. Okay, 4x squared. And then you times that by minus 4 and subtract by 4. So y will be negative 16x squared subtract by 4. Okay, that's the resultant function. Any questions?